Welcome to my Texas workshop. I'm Randy Lammers.
I'm Aaron Keevan.
This is worth knowing. Let's continue our series today on fastener finishes. We're going to talk about hot dip galvanized used in structural applications and mechanical applied galvanizing and plating. So hot dip galvanizing is an old, tried and true process that's been out there for many years, holding structural buildings together, bridges, towers, light towers, power line towers, all hot dip galvanized steel structures and hot dip galvanized bolting. So the process is really kind of simple, kind of basic. We dip it in a vat of molten zinc at 860 degrees Fahrenheit. Bring it back up and let it drain and dry. That's how it's done. So they do huge structural steel structures this way, and they do bolting this way. So this bolt would be also dipped and drained. The smaller items like the flat washers you see, the nut you see here, those items would actually be dip and spin. We dip it down in the molten zinc, we bring it back up, that spins rapidly to evenly displace the zinc over the metal.
Oh my gosh, Randy, please don't tell me you have a demo set up with a salad spinner again.
Sure, can I dip my salad spinner in molten zinc?
I don't think we have, that's OSHA approved.
Oh, that's not OSHA approved. Okay, well, we're not going to do a demonstration today on hot dip galvanizing. Now, Aaron, when we get into long length parts, like maybe all thread rod long length, what they'll do is after they bring it out of the vat, they'll actually bring it through a air ring that then blows the zinc evenly over the threads.
Right.
It works very good. We can do 3/8 diameter or about M6 or M8 in all thread rod and evenly run that zinc all the way across.
So the thicknesses on these things though, we're talking 40 to 60 microns. So that's 2/1000 of an inch. That's gonna be 10 times more than electroplating. Yeah. So it's really not gonna be ideal for smaller diameters. We're talking the limitation that we tend to look at is gonna be 3/8 of an inch. Correct. So you can't really go much smaller than that and not see some significant dimensional interferences.
Correct. Anything smaller than that, your threads are too fine and it's too much bulk.
That's right.
On there. So, all right, you're the smarty pants on specifications.
We're talking about A153, which covers all general sizes and shapes of steel. Everyone uses that one for structural steel, and sometimes fasteners get it included in that, but there's really a specific one that's used by, it's called ASTM F2329. So that will cover fasteners that need to be hot dip galvanized. And on the metric side, we're talking about ISO 10684.
Correct. Now, these specifications cover the process primarily. And what's interesting is you're going to find they're not going to talk about the accelerated salt spray test that you've heard us talk about in terms of this lasts for so many hours. They don't do that on hot dip galvanized because hot dip galvanized has a proven record out in environment, and the accelerated tests don't give it time to operate the way it's supposed to operate. So this thick zinc, it creates a patina as it oxidizes. And then that continues, it gets washed away and it recreates that patina. You don't have time in the accelerated test for that patina to do that. So therefore, we do not judge hot dip galvanized in an accelerated salt spray test. So instead, the galvanizing associations have done a very good job of defining, because they have the history on this, defining over time in different environments, this is how long you expect it to last. So the specifications give you your thicknesses and your processes, but they don't give you hours in salt spray.
Right, it's all about your service life at that point and not about that accelerated testing.
That's right, and they talk about it in years of service life. So again, good, tried and true finish on hot dip galvanizing.
Right. Now something to consider here of concern, just like we have the concern in electroplating, anything that's 39 HRC and above, we have to be concerned with hydrogen embrittlement. So we do not recommend hot dip galvanizing parts above 39 HRC.
Correct.
Right? And the other concern I can think of, we're dealing with molten zinc.
Yep.
So we're talking about 800 plus degrees
In Fahrenheit.
That could potentially affect the material itself. And that's a tempering temperature of the material. So you have to be very, very astutely aware of what kind of material you're using and ensuring you're not going to exceed the tempering temperature of the material.
Yes, so we have customers that will want to do property class 10.9 or grade 8. Be very, very, very careful there. Typically, there is some maximum temperatures a little bit cooler than 860 degrees Fahrenheit because you're too close to tempering temperature on those steels. So be aware of that. Let's go back to thickness in our nut fit, external threads. So we have to tap the internal threads oversize to allow for this heavy 2/1000ths of an inch of thick material that we've put on now our threads. So we tap them oversize. So these specifications actually call that out.
That's right, yeah, and that's for the nut member. So, and that process involves what? I think you would take a blank nut member in order to do that, and then, so that's galvanized before. After that's done, then you would do the tapping operation.
That is correct. And so when you do that, and so people go, well, wait a minute, I don't have any galvanizing in my internal threads. Well, you don't need it in the internal threads, because whenever you put those two together, the external thread, that heavy zinc on the external thread will protect the bare metal of the internal threads. But on the metric system, they allow you to do something different. Tell us about that, Aaron.
So I mentioned that spec earlier, ISO 10684. They actually have allowance for you to undercut the external thread. And when they do that, there's special marking that has to be done. It'd be a U placed next to the property class. Now, that can be detrimental to the strength of the fastener, so we do have to be careful with that.
Yes, that's why that U has to be there, because that tells you that these threads have been undercut and you no longer have the full strength of that property class. So it can be done so that you can use a standard fit nut, but be aware you have reduced the property classes in strength.
So we've explained the hot dip galvanizing, and now we need to talk about thick application of zinc with mechanical galvanizing and plating.
Correct. So mechanical, what do we mean by mechanical or mechanical applied? So it's very unique, and this one we're going to demo.
Okay, yeah, no molten zinc, but this will be a good demo.
Okay, so what we do is we take glass beads, which we have right here on the table in different sizes, glass round beads, and we put them in a barrel that looks like a cement mixer. We put the beads in there, we put our materials in there, we put our powders in there, our metallic powders, which you can do anywhere, zinc and tin and copper and aluminum. Just lots of metallic powders can be done with this, and you tumble it in a water solution and with some promoters, and the glass beads ping the metallic powders onto the surface of the fasteners.
Yeah, that's right.
Really, really cool. And so you just keep building up by putting more metallic powder in there, and you keep building up the thickness. And it's very precise in how you do this. So it's a very unique way of doing it, and guess what? Did I say anything that introduces hydrogen?
No, not in this process, because there's no electricity generated during this process.
That's right, so no hydrogen embrittlement. My friends, this is a good coating to go to in high hardness parts. So our socket head cap screws right here, our socket head cap screws that are up at HRC 45, mechanical zinc. So we do a lot of high hardness spring steel this way up in the HRC 50s, no hydrogen embrittlement, and our structural washers that are F436 that are high hardness. Also, we kept on about flat washers in terms we get this issue, and we can have this with hot dip galvanized too, where they nest together. And sometimes even the hot dip galvanizing process, you'll get about 4 or 5 washers that are stuck together. Yep. But in the dip spin process, it's a nightmare. not here.
Right, because the glass beads help to break those things apart.
Keeps
and
them
keep
apart.
them from nesting.
We can do high hardness parts like retaining rings. And what's unique about your retaining rings? What do they always want to do?
Well, they tend to want to hook together in other coating processes, but because of the glass beads, helps keep breaking them apart.
That's right. So we don't have any entanglement with those. We can do very, very small parts up to very large diameter parts with this as well. So it's a really great process for a lot of different geometries, and it works very, very good.
So we're talking about ASTM B695, and also on the metric side, ISO 12683. Those are the two standards that cover this.
That is correct. So these specifications do talk about accelerated test and salt spray hours, salt fog, salt spray hours. So we're going to talk about that. So down in the very thin, you can put very, very thin coatings on there that are in the 5 micron, 0.2 of a thousandth area. And that's about 36 hours, which is equivalent to our electroplating at 24 hours. And then you can go way on up, all the way up to the 40 to 60 micron area, real thick coatings that you can just keep building up. And we're going to demonstrate this here in just a minute. You can keep building up that thickness of the coatings by just adding more power and keep running these barrels. So it's very, very unique in that respect.
That's right, that's right.
So Mechanical Zinc's got a lot of features to it that we're really excited about. So you want to do a demonstration?
Yeah, I think so.
Let's get over there and demo. It's going to be fun. Okay, let's get started, Aaron. We've already put our PPE on, our safety glasses, and because I'm going to be handling chemicals, I have rubber gloves on. We put our water into our tub, our cement mixer,
Right.
and we've made sure that the pH is right. That's important. It needs to be down below 2, so we have that correct. And we've also put the glass beads. So the 3 sizes of glass beads we've showed you earlier, we've put those in here. The larger beads are somewhere about half of it, and then the other 2 parts are made up of the small beads. Now the beads also need to be as much in volume of beads as you have parts going in there. So that's already added in here. So let's get started. I'm gonna go ahead and turn this on. If you'll grab some screws that we've already cleaned.
Yep, and I've got these drywall screws that we cleaned.
Okay, these are 3-inch drywall screws. We've cleaned those thoroughly. Let's add those to the barrel. Get all of those in, and that's okay as I drop a few down there. All right, so those are now spinning in the barrel, and what we're gonna do is we're gonna start with a promoter. Now, I wanna start by giving Plating Systems and Technologies a very special thank you because they have supplied all of our ingredients we have today. They are the primary supplier in the world for products for mechanical galvanizing plating. So a big thank you for those gentlemen. They stepped up to the plate for us. Thank you very much. All right, so let's add some promoter to this. This actually promotes the adhesion. And so I have actually measured out by doing this before about how much I need. So we'll get that in there. Now that takes a couple of minutes. So we're gonna let that spin for a few minutes. And then the next thing we're gonna do, we're gonna watch for some foaming. We have a defoamer we can put in there if need be. So let that spin for a few minutes and then we'll start adding our other powders and I'll explain those to you. Okay, Aaron, that is probably about right. So we can stop this. That's kind of unique about this process is that you can start and stop. I don't know of another process you can start and stop with, but that's kind of cool. So our next step now, after we've done a promoter, is we have a special proprietary copper powder here. And so you have to do a copper flash, and that promotes adhesion. So we're gonna put this in there and start it again and do a copper flash. Matter of fact, let me get it started and I'm gonna put the copper in.
Good anchor for it.
Okay. It doesn't take much. Again, these would be pre-measured, so I have done this so I have an idea about how much this needs to be. So this will take a few minutes, upwards of maybe about 5 minutes, so we're gonna let that run. And what you're gonna see is you're gonna see these screws in there start to turn a copper flash, a copper coating. So let's let that run for a few minutes. Okay, Aaron, this ought to be about ready. I can see the copper in here, so let's turn that off so we can show our audience what we're talking about. Reach in there and grab small handful of screws. Okay,
Perfect.
you can see the copper coloring right there. And so we've laid down a flash coloring, flash copper on that, and that'll help the promotion.
Yeah, right. And then if we kind of compare them to what they look like before, you can definitely see a difference there.
Oh, absolutely, yeah. So you can see the copper flash now. All right, excellent. So we're gonna put these back in there, and now the next thing we're going to do is we're going to add then our zinc powder. So we're ready for that. And again, I've measured this out. Now it's important on the zinc powder to understand that you don't want to put it all in there at one time.
Right.
We build this up gradually. Again, you per weight, based on the thickness of zinc that you want to put on there, you pre-measure it out and then put it in. You really typically would add it probably about 10 times. So therefore, as it's tumbling, it's painting that on. The glass beads are painting on this zinc powder, and it'll just continue to build up the thickness. So pre-measure what you want for your thickness, but then you add it gradually. So the people that do this every day, they know just when
They
to
have
add
that
it.
exact formula. And
Exactly.
something interesting, an interesting fact here too, is that this is not time dependent. So this is all about how much you're actually using in the powder in order to get the desired thickness.
That's exactly correct. So, all right, so let's go ahead and add a little bit. We're going to, let's turn this on. And I've done this. I know about how many of these pinches that I should put in there.
Sure.
So let's go ahead and get one in there right now. We'll let it tumble, start doing the zinc. We're going to do this kind of quick for the show today. So I know that how much I need. Let me put one more in there for a while. Let's let that get started. Give that a few minutes, and then we'll put a couple more in there, okay?
Awesome.
Okay, Aaron, I think this looks about done.
All right.
We let it tumble. It doesn't really take very long for the zinc.
Yeah.
So let me reach in there, and again, they were copper the last time I pulled them out.
Sure.
And grab them in my hand correctly. And now, look at that. Now they're zinc.
Yep.
So that is zinc plating. Now, what happens in the process is that the entire barrel gets dumped out.
Yep.
It goes through magnetic separators so that the metal fasteners are separated out from the glass beads, and then it goes into a drying operation.
Just an air dry.
Yeah, just an air dry. And so then now we have as measured out properly, we have the right amount of zinc in thickness that's put on here. These screws right here, I'd probably put anywhere from 5 to 12 microns. And this is fully evenly covered, you can see them. And so they go out and they're dried, and then from there, if you want a chromate, you put a chromate on there. If not, they go on into packaging and off they go.
Out the door.
Mechanical applied zinc. So in conclusion, hot dip galvanized, dipped in molten zinc, excellent for external applications, and then mechanical plating, galvanizing, where we use our glass beads to ping metallic powders onto the metal.
Right, creates that nice even coverage. We know that it's not going to cause hydrogen embrittlement concerns, or HE, we call it in the fastener industry a lot.
Correct. So a point on the that I do want to make on the chromate is we found this, and this is, how do you learn this stuff? You get out there and get your hands dirty, my friends, and this is what we've been doing. So this is unique and kind of new to us. We learned that on the mechanical plating, that when a lot of times you want to put patches on, because we're doing a lot of high hardness parts like socket set screws, where patches are put on there frequently, that is a sprayed on nylon that's sprayed in a powder form, where they then have induction heated the metal. They spray it on. That can cause some condensation and start some zinc oxide forming. So trivalent chromate over the mechanical before you put a patch. Always remember that. That's something we learned recently.
Yeah, exactly right. The thermal shock values that you get from the trivalent chromate is
Yep, exactly.
incredible. So,
Comes into play there. So the chromates can be important.
we don't have to worry about nesting of flat washers.
Correct.
You know, conical and flat washers, those glass beads break those things apart, which
Correct.
is awesome.
Or keeps them from nesting to begin with. And a matter of fact, hot dip galvanized, make sure you understand that. Sometimes you can also get those that'll stick together too. So mechanical is a good way to go on that kind of
Exactly
product.
right.
Yep. Matter of fact, we use mechanical instead of hot dip or instead of dip spins a lot of times because of that reason. Hot dip galvanized, excellent for exterior applications and mechanical plating. Galvanizing has great benefits where you're concerned about hydrogen embrittlement and other specific applications. Hot dip galvanized and mechanical plating galvanized, both with unique properties, excellent fastener finishes, and that's worth knowing.
Be sure to subscribe so you can catch us on our next episode of Fastener Finishes.